Okay, so I'm going to work through each of these 6 problems on the first video. And feel free to, just fast forward to the problem that you have a question on or want to check all of them at the end of the video and then go back. But sometimes it's nice to hear and watch and see a solution as opposed to just reading it. So again, use the videos to what makes sense to you. Okay, so the first one, I'm going to make my entire denominator my u. All right, so like that, my u. So let's let u equal e to the 2x plus 2. Now the derivative will be itself with an extra chain. And that's perfectly fine because we have an e to the 2x up there. So we'll just have 1/2 du is equal to e to the 2x dx. And then we'll go ahead and rewrite this. So now we get the antiderivative. We have our 1/2 and our du. The 1 over u, obviously that's fine, but our bounds are going to change since I'm going to put a 0 in here. E to the 0 is 1 plus 2 becomes a 3. Now, if I say e to the 2 natural log of 3, e to the 2 times natural log of 3 plus 2. Well, this 2 right here can actually go up as an exponent of the 3. So it's e to the natural log of 3 squared, 9 plus 2. And that's nice. E to the natural log of 9 is just 9. So 9 plus 2, which is 11. So I can get my upper bound to be 11. Okay. And then that's our antiderivative of natural log. So it's 1/2 the natural log of the absolute value of u from 3 to 11. Both of those are already positive, so I don't necessarily need to keep the absolute value. So it's 1/2 natural log of 11 minus natural log of 3. How you want to simplify this and how much more you want to put things together, you could say, oh, that's 1/2 natural log of 11 thirds. Or you could say that's the square root, right? So natural log of the square root of 11 thirds. So any of those would be fine for your solution. Okay. Next, when you see natural log in a problem, for now, that's going to make a great u because we don't know how to take the antiderivative of natural log if it was by itself. We need something called integration by parts. So that's going to be a perfect u, plus it's trapped in a cube, so that makes it even better. So du is 1 over x dx, and we have a third of that, so a third of du equals 1 over 3x dx. So then I can go ahead and rewrite this. I like that going into a different color for the rewrite. So we get the antiderivative of 1/3 du, and it's going to be u cubed. Now let's look at our bounds. Natural log of 1 is 0. And the natural log of e is 1. So we completely are out of x. So this becomes 1/3 u to the 4th over 4 when evaluated from 0 to 1. So that's 1/12. And then it's 1 to the 4th power minus 1/12, 0 to the 4th power. So basically we have 1/12. All right. Now, next to, maybe I mentioned this in a video over the weekend, but just recognizing what to do in each problem and knowing like, okay, what's kind of the order that I go through to see, is it a power rule? Is it a u substitution? Is it natural log? Is it inverse trig? And one of the things I need to care, look, they both have the same denominator, number 3 and 4, but the degree of the first one, if you look at the degree of the numerator up here, that's higher than the x squared. So you have to use long division. Here, I wouldn't have to use long division. So it's good to kind of distinguish that. So long division, so let's go ahead and divide that out. So x squared plus 1 dividing into, and I want to go ahead and keep my placeholders here. So 0x squared plus 0x plus 1. So then x squared goes in x cubed x times, x cubed plus x. And then we subtract, that's our key, we subtract. So that's a 0, which is nice. We get negative x, and then bring down our 1. So our problem could be rewritten as the antiderivative of x plus negative x plus 1 over x squared plus 1 dx. Now that it's simplified, I'm going to look at that x squared plus 1. Maybe I might consider that being my u, like thinking, oh, maybe that's a good u. But the problem is I only get a 2x, and I still have the extra 1 there. So a good strategy, especially as you start to recognize that, wait a minute, there's probably an inverse tangent here because of that x squared plus 1. Let's go ahead and split this up into two fractions, as if like they would have needed a common denominator. So I'm going to split this up to x plus negative x over x squared plus 1 plus 1 over x squared plus 1. Because when I do that, that gives me an inverse tangent as the second one, which is really nice. Well, I guess the third fraction overall. So the middle one should, maybe consider a u substitution. Let u equal x squared plus 1. du is 2x dx. We're off by negative 1/2. So there's our negative x dx. So the middle one would be able to integrate, if we do this term by term, negative 1/2 1 over u du. So that's negative 1/2 natural log of the absolute value of u. We'll hold off to our constant at the very end. So then that's negative 1/2 natural log. Now, technically, I probably wouldn't need a set of absolute value bars here because x squared plus 1 will always be, always be positive. And then when we bring down this integral, it's just a normal power rule. So it's 1/2 x squared plus this term here. And then this is actually a perfect inverse tangent, right? There's no u substitution. Our a is 1. So then I know that that's plus, now usually it's 1 over a, so it's like 1. It's like 1 over 1 arctangent of x plus c. And remember, it's u over a as well, but x over 1. So, maybe I'll write it in orange here to highlight the final answer. Try to. So it's 1/2 x squared minus 1/2 natural log of x squared plus 1. Grouping symbol here is your option. And then there's plus arctangent of x plus c. Awesome. Now, don't forget we have one up here, and now the technique is going to be very similar to break this up into two different fractions. So this one actually is kind of, I didn't realize it's kind of a redundancy of that one. But that's okay. You can recognize that this can be broken up into x over x squared plus 1, and then plus 4 over x squared plus 1 dx. So I could have at least got a little variation with the x squared plus 1s, but it's okay, to contrast how things that are very close together like change, in terms of like, oh, here I would have to do long division and here I don't. So I'm going to do a u substitution on this first term, although based on our last example, it should be pretty straightforward. 2x dx, we're off by this time just a positive 1/2 plus x dx. So then this becomes the antiderivative of 1/2 of 1 over u du, which is 1/2 natural log of u, and I'll go ahead and just call that x squared plus 1 since I already sort of did it in the last example. And this is going to be plus 4, since we did it in the last example, arctangent of x plus c. And again, it kind of went a little bit quicker on that one, only because this I know would be 4 times 1 over x squared plus 1. So that that 4 just goes in front, and our a value is 1. Okay, next example. I know in the past, when we look at arcsine, sometimes it intimidates students. Oh, like arcsine, that's tough. It is, but at the same time, we don't know how to integrate it yet. So take that as a positive, I guess, that if you see arcsine, that's going to be your u, because to integrate arcsine by itself, you need to use integration by parts, which we don't know just yet. So let's let our u be arcsine of 2x. Watch the chain. So du, well, there's going to be times 2, but look at this. How nice. It's 1 minus 2x as a quantity squared, and then chain rule times 2 dx. That's exactly what's sitting, here. So this one actually is not too bad at all. So that and we don't have the 2, so we're going to make it 1/2 du is equal to 1 over the square root of 1 minus 4x squared dx. Excellent. And then we can integrate. So change of color. Sure, why not? So we're going to integrate 1/2, and then here's our du, and then it's 1 over u. So it just boils down to our natural log again. So 1/2 natural log of absolute value of u plus c. Again, little cumbersome because now we insert natural log of arc sine of 2x, and then plus c. Cool. And then our last one on this video. So this one, again, we'll break it up into 2 separate integrals because I should be hopefully at the point where I can recognize there's an inverse sine structure on the bottom there. So I'm going to make this into the antiderivative negative 8x over the square root of 9 minus 16x squared plus 1 over the square root of 9 minus 16x squared. Now, this first one, you should be thinking use substitution because we are 1 degree less in the numerator than the denominator. So that's always a good indication that would work. Let's let u equal 9 minus 16x squared. So then our derivative is negative 32x dx. We need a fourth of that. So a fourth of du is equal to negative 8x dx. Now, be really careful here. I'm anticipating, oops, sorry, not negative 1/4. I'm anticipating some students might accidentally think this is a natural log because we see 1/4 and then it's 1 over the square root of u du. But remember, square root is a power, and 1 over the square root of u is the same thing as 1/4 u to the negative half power. That could be simplified by a power rule. So we bump it up a power and divide by that power. So 1/4 u to the half divided by 1/2. So be careful about that. And then the 1/2 can, divide by 1/2, multiplied by the reciprocal. So you get 2 over 1 times 1/4, which is 2/4, which reduces to 1/2. And then the square root of u, or the square root of 9 minus 16x squared, plus whatever we get over here. And I think I mentioned this too. This common message we get from the AP board each year that be careful of the universal thinking anything as a reciprocal is natural log. It's only if it's the power of 1 in the denominator, not the square root, which is the half power. Now here, let's let u be 4x because 16x squared would have resulted from 4x as the quantity. So our derivative is 4 dx, so we're off by a factor of 1/4 here. So 1/4 du equals dx. And in this case, my a value is something more than just a 1, it's a 3. So when we integrate this, it's going to be 1/4, 1 over the square root of 3 squared minus u squared du. That's characteristic of arc sine. So we have this 1/4 here. Now, there is no 1 over a for arc sine, so remember that. Arc sine of u over a, so u over 3 plus c. And then so finally we can complete our problem here. Arc sine of u, which we said was 4x over 3 plus c. So again, if you were just fast forwarding to the end of the video, you can see the answers. Here are some more answers here. And then, if there's a question on any one of the first 6, you can certainly, go back and look through the video. And then here's a variation of all of the answers for that one. And again, I think I say this in all the videos, but, the goal of this section is to get to a point where you feel comfortable, you recognize sort of like the strategy, the antiderivative process, in terms of, okay, is this a u substitution? Is it natural log, inverse trig, things like that.